This is a problem that is on page 26 of our course lecture notes, where we're given 3 points on a circle, 0, 4, 3, 5, and 7, 3, and we're asked to determine the the equation of the circle that passes those 3 points. And not only that, we're asked to determine both forms of the equation. And the form that I'm most interested in is the form that clearly identifies the center of the circle and the radius of the circle, because I don't know what the center and the radius, where the center is located, or what the radius is. But that form is given by x minus h squared plus y minus k squared is equal to r squared. So I've got 3 problems here. I've got to find out what the h is, what the k is, and what the r is. So where is h and k equal to? Where is that point located, and what is the value of the radius? So I've made a small sketch here, and there's my 3 points, 0, 4, 3, 5, and 7, 3. And this is a rough sketch. I don't know where the center is and what the length of the radius is, but I think I can figure things out. If I've got 3 variables, I need 3 equations, and I'm going to get those 3 equations from the 3 points. So let's take a look at point number 1. Point number 1 tells us that we have a point at 0, 4. In other words, x is equal to 0 and y is equal to 4. So what that means is that 0 minus h squared plus 4 minus k squared is equal to r squared. That's going to be our equation number 1. However, I'd like to tidy that up a little bit. I'm going to rewrite it without the 0 minus h squared, because frankly 0 minus h squared is just negative h squared, which is in turn h squared. So I've got h squared plus 4 minus k squared is equal to r squared. And that's still my equation 1. I'm going to box that in because I'm going to come back to that later on. Now the other thing that I'm going to do is I'm going to do the same thing for equation number 2 and equation number 3. And I'm going to get equation number 2 from the second point, 3, 5. So let's do that. So from the point 3, 5, we are going to generate a value for x as 3 and y is equal to 5. So that's going to give us x minus h, which is 3 minus h squared, plus y minus k, that would be 5 minus k squared is equal to r squared. And that's going to be equation number 2. Let's box that in, because we'll come back to that. And now let's generate the third equation, which is going to come from our third point. And our third point is going to be the point 7, 3. In other words, x is equal to 7 and y is equal to 3. So that's going to give us x minus h. That would be 7 minus h all squared, plus y minus k. That's 3 minus k all squared is equal to r squared. And that's our equation number 3. Let's box that in. So now we have 3 equations and 3 unknowns. So 3 equations and 3 unknowns. And those unknowns are h, k, and r. Those 3 variables. So let's summarize. And what I've done here is I've listed all 3 equations, equation 1, equation 2, and equation 3. And what I've noticed is that all 3 equations give me a value for r squared. And so since I know that r squared is equal to r squared for all 3 of the equations, then why don't I make equation 1 equal to equation 2, say? And so I'll eliminate the r squared variable by setting equation 1 to equation 2, since r squared is equal to r squared. And so if I set equation 1 equal to equation 2, I have another equation that says h squared plus 4 minus k squared is equal to 3 minus h squared plus 5 minus k squared. And that's an equation that only has 2 variables in it. And with those 2 variables, what we can do is we can simplify this equation. Simplifying, we'll end up with h squared plus bracket 16 minus 8k plus k squared. That's what's going to be once I expand that using the binomial expansion for that term. And that's going to be equal to expanding the next term, 9 minus 6h plus h squared, plus, expanding the next term, I will have 25 minus 10k plus k squared. And so now I've got an equation which can be solved very nicely. In fact, what I notice right away is that I can deduct or subtract h squared from both sides of this equation. And if I subtract h squared, this is going to go and this is going to go. Not only can I subtract h squared, I can also subtract k squared. And I'm going to do that. Subtract k squared from both sides. And now I've got 16 minus 8k is equal to 9 minus 6h plus 25 minus 10k. And now I've got two variables, no squares. And I like this. This is getting better now, much easier. So I've got 16. I'm going to collect all the numbers and see what we come up with. So combining the 9 and the 25 is going to give me 34. And now I'm going to bring all the terms over to one side of the equation. I'm going to have 16 minus 34. 16 minus 34 is minus 18. And that's equal to 6h, minus 6h. And then we have a minus 8k over here and a minus 10k on the right side. So minus 10k plus 8k works out to be minus 2k. So we've got minus 2k on the right side of the equation. And again, what I've noticed right away is that all of those numbers are divisible by 2, so I can simplify my life by factoring out the 2, dividing by 2. So we're going to have minus 9 is equal to minus 3h minus k. In fact, I don't even like all those minus signs. Let's make them all positive by multiplying both sides by negative 1. So we'll end up with 3h plus k is equal to positive 9. And I'm going to really box that in because I'm going to use that as equation number 4. So now I know that 3h plus k is equal to 9. So we're going to take a similar approach with equations 1 and equations 3. In other words, since r squared is equal to r squared, that means equation 1 is equal to equation 3. And equation 1 is that we have h squared plus 4 minus k squared is equal to equation 3, which is the other r squared. In other words, 7 minus h all squared plus 3 minus k all squared. So r squared is equal to r squared in both cases. So we've got another equation with the two variables, and now we can set them equal to each other. So now I've got h squared plus 4 minus k squared is equal to the sum of the squares on the other side. Now we can expand both of these and we can say h squared plus, and we've got 16 minus 8k plus k squared is equal to, and I expand the right hand side, I've got 49 minus 14h plus h squared, and then I still have plus, and I've got to expand the last term. That would be a 9 minus 6k, and then plus k squared. And right away what you notice is that you can subtract h squared from both sides of the equation. The h squared term is gone. We'll subtract k squared from both sides. The k squared is gone. And now we've got a much simpler equation. 16 minus 8k is equal to 49 plus 9. 49 plus 9 is 58. And we've got minus 14h minus 6k. When all is said and done, this eventually reduces to another equation with only two variables, and that, if you apply your algebraic rules properly, reduces to 21 is equal to 7h minus 4k. And I'm going to box that in, really box that in, because now I've got two variables, h and k is equal to 21, and I had the same two variables in the other equation, so I'm going to call this equation number 5. So equation number 4 was that equation which said 9 is equal to 3h plus k. Whoops. 9 is equal to 3h plus k. And equation number 5 is 21 is equal to 7h minus 4k. Now you got a system of equations, and it's a system of equations that is linear. In fact, it's so easy that you can solve this algebraically very easily, but you can also solve it on your calculator. So you can use your calculator to solve this because it's in standard form. There's our corresponding x values here. They're all lined up, our corresponding y values here, and our corresponding constants on the right-hand side. We'll move them over to the right-hand side when we're entering them into our calculator. So when you solve on the calculator, you're going to get a value for h and you're going to get a value for k, and those values for h and k are 3 and 0. So the center of the circle is at the point 3, 0. So we can go back to our original drawing and label the center of the circle at 3 and 0. So let's go back here. So there's our center. Our center is at 3, 0. And so now you know a lot about this equation of the circle. We've got 3, 0 is our center, and there's our radius. Our radius to any one of those points, well, this one's a nice convenient one, our radius is equal to 3. So since we have a radius equal to 3, now we have everything that we need to know. So we've got x minus 3 all squared plus y squared, because there's y minus 0 squared, is equal to 3 squared. So the equation of the circle is x minus 3 all squared plus y squared is equal to 9. That is the standard form of the circle, and now you can easily convert that to the general form by expanding this binomial and putting it into the general form.